Next, we are going to talk about atom models. Atom models. How atom look like? Initially given by Thomson. Thomson's atom model. You have a positively charged sphere and the electrons are fixed over it. Electrons are fixed, electrons are embedded. Number of electron depends upon the type of atom what you are choosing. So this is the information given by Thomson. It has got some drawbacks. What drawbacks means? Electrons are not at rest, electrons are moving, but Thomson says that electrons are embedded. So this is a major drawback. Second drawback, the spectrum what you are getting in the output side is a continuous spectrum. But 1300 Armstrong unit, only one line spectrum is observed in Thomson's method. There are so many spectral series available. He could not explain the type of spectral series what is given. Of course, he named as watermelon atom model. This is otherwise known as watermelon atom model. Whatever may be the case, Thomson's method, Thomson atom model, not explain the basic atomic structure. Then comes Rutherford atom model. To discuss some positive charge is present inside, he performed the experiment, gold foil experiment, alpha particle gold foil experiment by Rutherford. This is lead chamber, radium, radioactive material, radium. Here gold foil, thin gold foil. Gold foil means oil itself is very thin only. Small sheets. So many particles, alpha, beta, gamma radiations are coming out. You are considering only alpha particles. How means alpha particle is positively charged? You can remove the negative beta and gamma and all. Alpha particle, which side alpha particle is coming out, that side alone you project and do the experiment. Ignore the beta and the gamma rays. Fine pencil of rays by two slits S1 and S2. And when this alpha particle strikes the gold foil, he observed some phenomena. What observation? Few alpha particles are moving or scattered in a small angle. Very large percentage passes through, and a very few percentage are exactly returned in the opposite direction. Why it is exactly returned in the opposite direction? He tried some experiments and he observed that initially alpha particle is positively charged. So this gold foil consists of some positively charged core. Because of this positive, when it is going, actually it is not hitting, it is going up to a small distance and then returned back. Actually, it is a ripple. This we call it as distance of closest approach. electron alpha particle is moving in that beam. Alpha particle movement up to a particular distance, so kinetic energy. After that, it returned back potential energy. So that kinetic energy and potential energy are equal at equilibrium position, where it exactly turned back. Equilibrium points. Kinetic energy by the alpha particle which is moving is equated to electric potential energy. Equate these two. What do we have? EK is equal to EP. EK is equal to, this is half mv square. Electric potential energy formula Q1 Q2 by 4 pi epsilon naught R. Q1 alpha particle 2E. ZE actually Q is Ne ma. N in the case of alpha particle helium 2He4. So 2 atomic number. Q2 gold nucleus. So general nucleus charge is Ze. Z represents number of protons, atomic number, by 4 pi epsilon naught R. In our case, we are writing as R naught, distance of closest approach. I want to calculate R naught. 2 ZE square by 4 pi epsilon naught EK. So you can calculate the distance of closest approach. So by this, Rutherford inferred, you have a nucleus inside. Electrons are not fixed. Electrons are revolving around the nucleus. That is the initial idea given by Rutherford. How many electrons depends upon the type of atom what you are considering. But here also we have some drawbacks. What drawback? He assumed classical electromagnetic theory. The discussion by Rutherford is classical electromagnetic theory. So classical electromagnetic theory, any charged particle which is revolving should radiate energy. Any charged particle. Electron is a charged particle. It is revolving energy. It is revolving around the nucleus. So it radiates energy. So nucleus, electrons are revolving. So every time when it is revolving, it is radiating energy. Means what is happening, sir? Electron will lose its energy and finally it spiral and fall into the nucleus. Nucleus, electrons are dropped, means nucleus having protons, positive charge. Electrons are negative. Equal number of protons and neutrons only we have. So nucleus become unstable. Nucleus unstable means the atom is unstable. Actually, it is not happening. Nucleus is very much stable, atom is very much stable. So the assumption made by Rutherford is wrong. This is the first drawback. Second drawback is the continuous spectrum what you are expecting. Frequency of revolution of electron, frequency of radiation emitted, these two are equal. That is his assumption. But based on that, you should get a continuous spectrum. 1300 Armstrong unit line spectrum only he observed. Because of these two factors, Rutherford atom model has been discarded. Age-old experienced scientist Rutherford. So the Rutherford atom model discarded means entire physics field is stunned. Then comes Bohr atom model. Actually, Niels Bohr is one of the students of Rutherford. Some other research he was doing, 1909 to 1911, this concept. When his professor's theory has been discarded, he took this as a challenge and he has done the work. Almost 80 to 90% he could explain. And after Bohr atom model also, we have some drawbacks. We got Sommerfeld atom model, and finally all scientists put together, they gave one atom model, vector atom model. But Bohr's atom model only paved the way. 70 to 80% of type of an atom, atomic structure. Bohr atom model gave a clear idea. So here we are going to talk only about the principle of Bohr atom model. Just to outline alone you are going to see, because it is a huge concept. Bohr atom model postulates, two postulates we have. Number one, electrons are revolving around the nucleus in a certain specified orbit without radiating energy. Rutherford says it radiates energy. He is telling it is not radiating. So just like that we can tell it, no, it is not. It is not following classical electromagnetic theory. If it follows classical theory, then only it should emit radiation. It is not following classical theory because classical theory, the particle should have appreciable mass. Electron mass is less than the normal expected. So, electrons which is revolving is not following the classical theory. So, it is not emitting radiation. So, first problem is solved. Second, frequency of revolution is equal to frequency of radiation. It is not radiating anything. So, frequency of revolution, frequency of radiation is also not applicable. So, Bohr assumed here electrons revolving around the nucleus in a certain specified orbit without radiating energy, called non-radiating orbits. The angular momentum L is equal to nh by 2 pi. MVR is called angular momentum, that is nh by 2. This is first postulate. Second postulate says, sir, it is not emitting energy at all. It is emitting, but when it is emitting, when the electron jumps from higher orbit to lower orbit, it is emitting radiation. E2 minus E1 is equal to h nu. E2 minus E1, higher orbit energy, lower orbit energy. H is called the Planck's constant. Nu is called the frequency of radiation emitted. So these are the two basic postulates of Niels Bohr. From that, he calculated radius of nth orbit, electron revolving around the nucleus in hydrogen atom. He found out the radius value. Actually, he initiated the idea. Electron revolving circular path. Circular path means what is the meaning? Centripetal force. Nucleus is having positive charge, electron is having negative charge. So two charged particles, Coulomb force, he equated. Using these two, he found out the value of radius. N square, h square, epsilon naught by Z square by m. This is the expression for radius. Hydrogen atom for nth orbit. Number of orbit, Planck's constant, This is permittivity of free space. Z atomic number, charge, mass of the electron. Then kinetic energy, potential and electric potential energy. Use these two. He found out the total energy of the electron beam, of the electron which is revolving. E total is kinetic plus potential minus z square m e power 4 by 8 epsilon naught square n square h square. N term. Kinetic energy calculate, potential energy calculate, add these two. Sir, why negative value? Electrons are bounded to the nucleus. Always. Charge of the electron negative. It is bounded to the nucleus. Simply it is not. Always when it is revolving, it is bounded to the nucleus. So minus. Substitute the values. You will get. This is in joules. Electron volt you have to convert. Minus 13.6 by n square electron volt. Sir, joules to electron volt, how can we do it? 1 electron volt is 1.6 10 power minus 19 joule. 1 joule is 1 electron volt by. So any value given in joule, if you want to convert it to electron volt, divide by the charge. That's all. Electron volt to joule you want to convert means multiply by the charge. So this is the final expression for total energy of hydrogen atom. What happened to the spectral series, sir? He could clearly explain the spectral series, but it is named after many scientists. Lyman series, Balmer series, Bastian series, Brackett series, Fun series. Using first postulate, we have calculated this. Use the second postulate. When electron jumps from higher orbit to lower orbit, energy is liberated. So E2 minus E1 is equal to h nu. You calculate the frequency. Then final expression. Nu bar. This is called wave number 1 by lambda R into nu bar is equal to 1 by lambda R into 1 by n1 square minus 1 by n2 square. Lower orbit, higher orbit. R is called Rydberg's constant. 1.094 or 97, 10 power 7, 1 by lambda. So meter power minus 1. This is our value. When electron jumps from higher orbit to first orbit, some kind of spectral series emitted. Lyman series. When electron jumps from higher orbit to second orbit, Balmer series. You calculate wavelength for that. Electron jumps from higher orbit to third orbit, Bastian series. Higher orbit to fourth orbit, Brackett. Higher orbit to fifth orbit, Fun series. Why we are giving different scientist name for each orbit? Actually, everyone has contributed something for the physics field. When you calculate lambda, you can see it lies in ultraviolet region. Let it be from infinity, it comes to first orbit, or second orbit to first orbit. You calculate lambda, it lies only in ultraviolet region. Lyman has done some work in UV region, so Lyman series. Balmer is not a physicist, he is a mathematician. He has done some work in visible light. So this is visible region. An electron jumps from higher orbit to second orbit. Higher orbit, third to second or infinity to second, you calculate. You will get range of wavelength. That wavelength lies between 4,000 to 7,000 Armstrong unit, visible range. Below 4,000 UV. Bastion series, bracket series, fund series. All the three lies in infrared region. Electron jumps from higher orbit to third orbit, higher orbit to fourth orbit, higher orbit to fifth orbit. Maybe it is near infrared region. This is far infrared region. Infrared region, that's all. You can calculate lambda for any given value. Rutherford atom model has got some drawbacks. Few has been rectified by Niels Bohr, but Bohr atom model also has got some drawbacks. It is applicable mainly for hydrogen atom alone, not for complex structure. Hydrogen atom alone it is applicable. Complex atoms, if you go, it is okay, but it fails. Next comes Sommerfeld atom model. He could explain fine structure of spectral lines. Bohr atom model could not explain Stark effect and Zeeman effect. That means when the electron, the so-called atom is placed in electric and magnetic field, how it is behaving, he could not explain. Fine structure of spectral lines, he could not explain. Complex structure of atoms, no. Only for hydrogen atom, this theory exists. Then Sommerfeld atom model could explain fine structure of spectral lines, but he could not prove the other things. Then all the scientists put together formed the vector atom model. It paved the way, including the quantum numbers. Okay. So that we will discuss later. Next, excitation and ionization potential. Excitation, ionization, potential energy. You should know the difference. Excited means you are giving some energy for the atom. Directly for atom, you can give it for solid. That solid has got so many atoms. One particular atom is excited. So electrons are shifted to higher orbit. When electrons are shifted to higher orbit, naturally it has to come down. It cannot stay there because electrons, you are giving some energy, it has gone to higher orbit. There it cannot stay, it has to come down. N is equal to 1, we call it as ground state. N is equal to 2, we call it as first excited state. N is equal to 3, second excited state. E is equal to minus 13.6 into 1 by n1 square minus 1 by n2 square. Energy difference. Lower orbit, higher orbit. So, when electron jumps from basic formula is what ma? E is equal to minus 13.6 by n square electron volt. N is equal to 1. E1 minus 13.6 electron volt. E2 N is equal to 2 minus 13.6 by 2 square minus 13.6 by 4 minus 3.4 electron. E2 minus E1 if you calculate, you will get minus 3.4 minus of minus plus 13.6. So you will get 10.2 electron volt. First excitation potential energy. Sir, I want excitation potential. Divide by P. W is equal to Q into V. V means W by Q. Only one electron, sir. EV. Right by charge. So 10.2 electron volt is first excitation potential energy. 10.2 volt means excitation potential. Sir, next second excitation, how to calculate? Minus 13.6 by 3 square, 9, 1.52 electron volt. So minus 1.52 electron volt plus 13. Subtract. 12.09 electron volt. Second excitation potential energy. Like that it goes. Ionization means removal of an electron, only one value. E is equal to minus 13.6 by m square. You are removing the electron from the first orbit to infinity. Infinity means 1 by first orbit means n is equal, n1 is equal to 1. Infinity, 1 by infinity, 0. So 13.6 electron volt. Ionization potential energy is 13.6 electron volt. Ionization potential 13.6 volt. Sorry. Thomas, this is excitation and ionization potential energy and potential. So atomic physics part 2 we have done. Afterwards we will discuss some problems based on this. Thank you.